Okay, the next chi-square test we're looking at is the test of independence. And it uses a contingency table of observed data values, and it also uses an expected table, but we don't have to have the expected table for StatDisk, but we do have to have it for one or two of your questions in MyOpenMath. So we're given your test statistic. If you want to calculate by hand, of course, we're going to use technology except on the expected table, and we just have to do a little bit of math on that. Just calculator work, no big deal. Okay, so here's what everything means. And a test of independence determines whether two factors are independent or not. And you saw this independence and dependence in I think chapter 3 of probability topics. Just a note here, you're not the number of degrees of freedom for the test of independence is degrees of freedom, df, is equal to your number of columns minus 1 times your number of rows minus 1. I think StatDisk gives that to you. If not, this is what it is. The expected value for each cell needs to be at least 5 in order for you to use the test. And I don't think I give you one there that they're not less than 5. So in a test of independence, we state the known alternative in words. Since the contingency table consists of two factors, the null hypothesis states that the factors are independent. We think there's no relationship. The alternative is going to say that they're not independent or they're dependent. They're kind of connected, I guess. So we're looking at an example in a volunteer group. Adults 21 and older volunteer from 1 to 9 hours each week to spend time with a disabled senior citizen. And the program recruits community college students, four-year college students, and non-students. And the table below is a sample of the adult volunteers and the number of hours they volunteered each week. So this is observed. And they wrote it down. So there are 3 rows and 3 columns. And we add the totals in here because we need those to get your expected value table. Okay. So, again, we're asking, it's kind of redundant, is the number of hours volunteered independent of the type of volunteer. Okay, so our null is going to be the number of hours volunteered is independent of the type. We're going to say, you know what, it doesn't matter what type you are. And then we're going to say, you know what, the number of hours volunteered is dependent. You know, I would kind of think, looking at the numbers, let's see. 150, well, just kind of looking at your data. I really don't know without looking at the test. This 150 kind of stands out to me. Maybe non-students do more than, but then you got the 133 here. So we'll have to see if it's statistically significant. Okay. Now I do the expected table. Okay, so I've calculated this for you. And now I have to show you how to calculate it. So, actually, I'll need to move it down. So, for the 1 to 3 hours community college student, it's just a little bit different. So, we go back to the observed. And I have the formula here. Row total times column total divided by total number surveyed. So, for 1 to 3, 255, column is 298, total is 839. 255 times 298 divided by 839 is 90.57. And they're rounding these to 2 decimal places. Okay, 4 to 6, community college. Again, would be 255 times the 379 divided by 839. And so on and so forth. So I calculated these out for you just so that you know what we're doing. Okay. Giving you a graph here. And then let's see what StatDisk tells us. Okay, so I'm giving you an answer here. This takes a little bit, and one of the problems asks you to find the expected table. So look these over really good, and you should be okay with that. So let's see what StatDisk gives us. Okay, we've copied it into StatDisk, and we're going to select columns 1, 2, and 3 of the observed values. They didn't give us a significance level, so we're going to assume 0.05. That's kind of the standard. And notice that chi-squared is equal to 12.9909, and phi is going to be equal to 0.0113. Let's see what word gives us. Let's see if I can make these side by side. 12.99, 0.01. Exactly, so make a decision. P is less than alpha. Notice that they use P is less than alpha, or they don't use P is less than or equal to alpha. I've actually never seen a P value that equal alpha that we had to make a decision on. So let me know if you have any questions. Thanks.